Hello, this is Geometry 2-6, and we are continuing our proofs. And today we are going to be talking about algebraic proofs, which if you're feeling a little uncomfortable with proof writing in general, this one's actually not too bad. The first thing you want to do is write down all of these properties of real numbers. Make sure that they're in your notes. They are also found on page 136 of your textbook. And we're going to be using these properties, the addition property, basically stating that you can add the same number, in this case C, to both sides of an equality or an equation, and you'll get the same thing. Subtract the same number from both sides, they're still equivalent. Multiply the same number to both sides, still equivalent. Divide both sides by the same non-zero number, and it'll still be equivalent. Reflexive property is that A is equal to A. It's kind of like when you look at yourself in the mirror, you see yourself. So symmetric means that you can reverse them. So if A equals B, then B equals A. Transitive property is a good one. If A equals B and then B equals C, you can kind of get rid of B and A equals C. And then of course substitution, if A and B are equivalent, then A may be replaced by B in any equation or expression. And then of course the distributive property that we have there. So we're going to be using these to write algebraic proofs. And so before we begin, it says here, prove that -5 times x plus 4 equals 70, or if -5 times x plus 4 equals 70, then x equals -18. Write a justification for each step. And when it says justification, that's the hard part, or the frustrating part, I guess you should say. These are our justifications. When it says justification, you're going to be writing one of these properties in these blanks. So I mentioned before that when you have a proof, the good news is that you already know the answer. So normally in algebra, we would ask you to just solve this equation, and you would solve it. In this case, they already told us the answer is -18. We know it's -18, and here are all the steps involved. But what we have to do is justify each of those steps, okay? So kind of like a proof, we're going to start here, and we're going to put given right there, because this is the original equation that we were given. And then you can see here that we're taking -5 times x, which is -5x, and then you're going to add -5 times +4. And so that's the distributive property. So our justification is distributive property. You can abbreviate property by prop. That's totally okay. And then you can see here that we've got -20 right here, and that's the substitution property. And that one might seem a little strange to you, substitution. By the way, be careful not to abbreviate substitution SUB, because it can also be subtraction. So be careful with that one. Alright, so basically what we're saying is that we're replacing -5 times 4 with -20, because we know that -5 times 4 is the same thing as -20. And that's why we're using the property of substitution. Okay, and then we have here in red, you can kind of see what happened here, is I have the same equation from before, but I'm adding 20 to both sides. And we just said earlier that when you add the same number to both sides, you still have an equivalent statement. So that's the addition property, add prop EQ. See, you can do add prop EQ for addition property of equality, but with substitution, you don't want to put sub, because it could be subtraction. So anywho, then after we get -20 plus 20, this one is going to be, again, substitution property here. And again, that's because we know that -20 plus 20 is equivalent to 0, so we just get -5x. And 70 plus 20 is the same thing as 90, so therefore we're replacing the 70 plus 20 with a 90. And that's why we call that substitution property. Okay, and then in the next step, we're dividing both sides by -5, so that's division property of equality. Division prop EQ. And then lastly, we're going to replace the -5 divided by -5 with a 1. And 90 divided by -5 is -18. And so once again, we have substitution properties. So we have a lot of substitution property. So in an informal kind of a way, this is basically a 2-column algebraic proof, but they just didn't call it that. We did prove it, we justified each step, and so now we're going to ask you to do that in part C. In part A, it's just giving you one statement. It's not asking you to prove the whole thing. It's just asking you to see which property belongs to A and which property belongs to B. And then in part C, that's where they actually want you to solve it all, although you already know what the answer is, but write a justification for each step. So in part C, it will be a lot like example 1, but in A and B, you're just being asked to write the property for that specific sentence, okay? So now we go to example 2, and now you can actually see the formal proof type process. It's going to be a lot like what we just did, but now we have a T-table where it says statements and reasons. And so let's read what it tells us here. It says, if the formula to convert a Fahrenheit temperature to a Celsius temperature is C equals 5/9 multiplied by F minus 32, then the formula to convert a Celsius temperature to a Fahrenheit temperature is F equals 9/5 C plus 32. And a lot of you have probably already seen these formulas before for converting between Fahrenheit and Celsius. So in this case, if you know what the Fahrenheit temperature is, you can plug it in here and then get the Celsius temperature. And in this case, you're going backwards, and then you can give the Celsius temperature and then plug that in and end up with a Fahrenheit temperature. So basically, they want us to show how one begets the other. It says, write a 2-column proof to verify this conjecture. So the first thing you want to do is, like we said before, always start with the given and a proof. So from the directions, I need to extract what the given is. And they tell me from the get-go that C equals 5/9 times F minus 32. That's my given. But in the end, it tells me that it basically says, if this nonsense, then this nonsense. So a lot of other stuff written in their words, but at the end of the day, they want us to prove that if we start with C equals this, then we end up with F equals this. And so we're going to do that here. So I've already kind of filled in the first step, which is to start with the given. And so now, the first thing that we want to do is multiply both sides, let me see how I'm going to write this, by the reciprocal of 5/9. So I'm going to go 9/5 times C equals 9/5 times 5/9 F minus 32. Okay? So what I'm doing here is, if I was actually going to solve this, I'm going to, and you can even do some different colors so you can kind of see what's being added here, the 9/5. Okay, we already had 5/9, so I want to get rid of the 5/9. So if I multiply it by 9/5, then these two will be a 1. They'll cancel. 9 times 5 is 45. 5 times 9 is 45. So you get 45 divided by 45, which is basically 1. Okay, so when I do that, I'm going to end up with 9/5 C equal to F minus 32. Okay, but before we go any further, we know that whenever we multiply both sides of an equation by the same number, in this case 9/5, then our reason is multiplication property of equality. Okay? And now what I've done is, if you remember from the previous example, is that I'm replacing this 9/5 times 5/9 is 1. So I'm replacing this whole thing with a 1 here. Instead of it being 9/5 times 5/9, it's just going to be 1 times. So this is going to be my substitution property of equality. Substitution property of equality. Okay, and now if you look at what I'm asked to prove, I need the F by itself. So I need to add 32 to both sides. So I'm going to go 9/5 C plus 32 equals F minus 32. Let's put that in a different color. So what I've done there is I've rewritten the 9/5 C. I've rewritten the f minus 32, that's all in the blue, and I'm adding to both sides the 32. And whenever I add the same amount to both sides, we call that addition property of equality. Okay? And then my fractions are getting kind of crazy there. But my next thing is to substitute. So I'm going to have 9/5 C plus 32. And over here, we're going to get negative 32 plus 32, which is 0. And so we're going to replace the negative 32 plus 32 with what it equals, which is 0. And so that's, again, substitution property. I'm substituting substitution prop EQ. So I'm replacing this piece right here with 0. Okay, so now the only problem that we have left is that it's not in the right order. And these crazies are being really loud, so we're going to close the door. Okay, so anywho, sorry about that. We've got, this is kind of backwards. We wanted to say F equals, not equals F. So that's going to be our last step. And so then right here we're going to squeeze it in. F equals 9/5C plus 32. Squeeze it in there. Good job. And that is the reflexive property. Remember, so that if A equals B, then B equals A. So we're just reversing the order there. So that is reflexive property. Reflexive property. Okay, and then of course, if you remember our little Helmos, that ends our proof right there. And there you go. That is how you can use algebraic proof in this particular case. So, all right. Oh, I said symmetric and I put reflexive. I'm so sorry. Hold on. This should not be reflexive. I said if A equals B, B equals A. But reflexive is A equals A. So I should have put symmetric, sorry. Symmetric property is when you say A equals B, then B equals A. All right, so now we want you to try this guy. There's an A and a B, so you'll have to pause this and then write it down. This is part A, 2-column proof, and then this is part B. All right, and then we're going to do one last thing before our last example, which is right here. And that is to just kind of bring into geometry side. We saw all the properties for algebra. There are a couple of properties that are in algebra that are also in geometry. For example, we have a reflexive property for algebra, symmetric property in algebra, transitive property in algebra. But I wanted to give you some examples of how you can apply these to actual geometric shapes like segments and angles. So the reflexive property for a segment would be something like AB equals AB. Symmetric property would be if AB equals CD, then CD equals AB. And then of course transitive, if AB equals CD and in turn CD equals EF, then you can eliminate CD and then AB equals EF. And the same is true for angles. So reflexive would be that the measurement of angle 1 equals itself. The symmetric property would be that you can reverse the order, right? So the measurement of angle 1 equals measurement of angle 2, and that means that the measurement of angle 2 equals the measurement of angle 1. So you reverse the order there. And then of course transitive, if the measurement of angle 1 equals the measurement of angle 2, and then in turn the measurement of angle 2 equals the measurement of angle 3, then again you can X out the middleman, the angle 2, and then the measurement of angle 1 equals the measurement of angle 3. So that's just applying them to more geometric shapes and objects as opposed to just algebra. But here we have another example, our last example, and I kind of have to get this guy out of the way because as you can see, this has 11 steps, and they're gonna be in the way. So I'm gonna try to not overcrowd the steps there. But here we go. Let's see here. Let's try this color over here. Okay, so if angle FGJ, which is right here, FGJ, is congruent to JGK, so this guy is congruent to JGK, this guy, right there, FGJ, JGK, okay. Then it says, and of course my diagram does not, it's not to scale because they don't even look the same, but according to the information that they are the same. And then it says JGK is congruent to KGH. So now this angle is congruent to that angle, okay? Then x equals 6, okay? So write a two-column proof to verify this conjecture. So given, we always start with the given, okay? So we're going to say angle FGJ is congruent to angle JGK. And I'm going to try to squeeze it in here, angle JGK is congruent to angle KGH. Now, as long as the two given statements are the same type, in other words, this is an angle congruent to an angle, angle congruent to an angle, then you can go ahead and put both of those givens in the same sentence or in the same step, if that makes sense. If this was an angle congruent to an angle and this was like a midpoint statement, then no, you couldn't put them in the same line. But in this case, they're the same type of statement. So there we go, and this is given. And then the next thing that we need to do is to use substitution, because we know from our diagram that FGJ is actually 6x plus 7. So we're going to say 6x plus 7 is equivalent to JGK, okay? So actually I wanted something a little bit different here before I get too crazy there. We have to have another step in here first, so let me just hold up. We don't know what JGK is as far as the algebraic expression. We weren't given one. So we're actually going to use a translator property first. And so we have FGJ's congruent to JGK, and in turn JGK is congruent to KGH. So we can get rid of the middleman, and we can say that angle FGJ is congruent to angle KGH. And that is transitive property of equality. Trans-prop equality. Okay? And now that we have those angles congruent to each other, now we can actually go beyond that little guy, and if these are congruent, then that means that the measurement of angle FGJ is equal to the measurement of angle KGH, and that's because of definition of congruent. Definition of congruence, okay? And now we can use substitution, because we know that FGJ is 6x plus 7, and that KGH is 8x minus 5. And this is substitution, because we're replacing substitution. I'm going to write that down correctly, because we're replacing what the angle measure is equivalent to based on the diagram. So there we go for step 4. 6x plus 7 equals 8x minus 5. And now it just pretty much becomes an algebraic proof, and you can kind of probably do these next few steps in a variety of different orders, but I'm going to go ahead and do it my own little way here. Let's see here. I'm going to then take plus 5. Okay, so we're going to go 6x plus 7 equals 8x minus 5. And if you want to know what I'm talking about, what I'm going to do in step 4 is I'm going to add the 5 here and add the 5 on the other side as well. See how I left some space there? And then that's going to give me 6x plus 12 and then 8x. So first of all, I've kind of skipped some steps here. So step 5, we're adding 5 to both sides, so we get addition property of equality. And then in the next, in step 6, what I'm doing is I'm replacing 7 plus 5 with 12, and I'm replacing negative 5 plus 5 with 0. So that's substitution. Okay, and then we want to put our our x's on the same side as well. So we're going to go 6x minus 6x plus 12 goes 8x. And so what I'm going to do now is I'm going to subtract 6x from both sides. So you can see that I have the 6x from before, and then I'm subtracting 6x from that side, and then there's the plus 12 that was already there, 8x, and then minus 6x. This is going to be subtraction property. And then I'm going to use substitution. Since 6x minus 6x is just 0, we're going to get 12 equals 8x minus 6x is 2x. So I'm replacing the 8x and the minus 6x with the 2x and replacing the 6x minus 6x with 12. So that's going to be substitution property. So we've got, I'm running out of room, substitute. We're almost done. Property. And then we're going to divide by 2. So let's see if I can write this down here. Let me see. 12 equals 2x. But we're going to divide by 2, divide by 2. And I'm kind of crowding number 10 there, but this is still step 9. So I'm dividing both sides by the same number. So that's the same non-zero number. That's division property of equality. And then step 10, I'm going to kind of write it over here. Sorry, because I'm running out of space. 12 divided by 2 is 6. And 2x divided by 2 is just x. And that's going to be my substitution property again. Replacing 2 divided by 2 with a 1 and 12 divided by 2 with a 6. Substitution. And then my last step is, this is still kind of backwards. It shouldn't say 6 equals x. It should say x equals 6. Like number 11 will be that x equals 6. To write it in a different order, that is symmetric. Let's not get it wrong this time. Symmetric, OMG, property of equality. Yay! I actually managed to fit that in there. I thought I wasn't going to be able to. Sorry for the crowdedness there, but that is basically how I can write a two-column proof to verify this conjecture. So now you will try this last example. This is part A, and then of course part B. And once you've done that, you will have completed your notes for this lesson, and I will see you in class, and thank you for watching.